Dear students, welcome to the new chapter, Surface Areas and Volumes. Here is the main objective of this chapter. There are mainly two objectives. Number one, surface area of these 5 3D shapes: cube, cuboid, cylinder, cone, and sphere. And the second objective is volume of cube, cuboid, cylinder, cone, and sphere. Cube, cuboid, cylinder, cone, sphere. So have a note of this: surface area of these 5 shapes and volume of these 5 shapes. Let us see the similarity and differences between cube and cuboid. That's our first lesson. It will be detailed with the net of a cube and cuboid. You know, the net means if we have a box of cube, when we cut and open it without damaging the edges, we will get the net in this form. And the net of a cuboid will be approximately something like that. It depends on the edges. The height can be less or more. It depends. Again, we will come to it in a minute. So let's see the details. At first, similarity between a cube and a cuboid. Both of cube and cuboid, both of them have 6 faces. What are the faces? Up, down, front, back, left, right. So we have 6 faces for both cubes and cuboids. Vertices, edges, 4 at the top and 4 at the base. So total 8 vertices for both cube and cuboid. 12 edges. Edges are the meeting point of different faces. We have 1, 2, 3, 4. So 4 at the top, 4 at the base, and 4 at the as the heights. So 4, 4, 4. So total 12 edges. And we need to know about lateral faces. Lateral faces means the faces which are on the sides except at the top and the base. So from total 6, we have to remove the top and the base. So we will have 4 lateral faces for both cubes and cuboids. Let us see more details about the net of a cube. As we said, this is the net of a cube, and this is the general format of drawing a net. There are many ways, we will come to it. This is usually representing up and this is down. And while we represent the lateral faces of a cube and cuboid, remember, left and right are never together. Front and back are also never together, which means there will be a space between them. When we cut and open it, exactly you will get the idea. So up and down are never together. There will be a space between them. Left and right are never together. Front and back are never together. That's to be noted. And different types of nets of a cube are given here. It depends on how you cut. This is the standard form. The top and bottom, it need not be on the same side. It can be one to the left and one to the right. It can be any of these forms. And it can be 3 together, 3 again together. But remember, always never up and down together, left and right together, front and back together. Each one will have a space between them. These are different types of net that you will get when you open a cube. Now let us see more about surface area of a cube. So surface area, you know, a cube is made up of squares everywhere. So the area of one square alone is a square, because side times side. If one of the side is a times a is the area of a square, because you know area of a square is side times side. Or we can say it is a square if a is the side. So this is a square, again a square, all the sides will be the same. That's why we call it as a cube, like a dice. So we have 6 squares, so total surface area will be a square plus a square plus a square, which will be 6a square. That is total surface area, or we simply write it total surface area of a cube is equal to 6 A square. Now, what about lateral surface area? We discussed lateral surface area means top and bottom will not be considered. So we have 4 faces. So it will be 4a square. Lateral surface area of a cube is 4a square. Now let us consider the net of a cuboid. In the net of a cuboid, we have to be a little bit careful because the length, breadth, and height will be different from different shape. But for a cube, it's so easy because all sides are the same, because all faces are made up of square. Here, let us say this is the length and this is the breadth. So this will be the height. So when we consider the area, total surface area, we have to take the area of each of these faces. Now, this is the breadth and this is the height. So this will be B times H. This is length and height, so this will be L times H. This will also be L times H. This will be B times H. This will be BL or L times B, and this also will be L times B. Now when we consider the total surface area, which is also written as only surface area of the shape, here it will be BH, BH, so 2BH, LH, LH, so 2LH, and LB, LB, 2LB. So we have 2 common. We can take it outside and let's write it in an order. LB, BH, LH. 2 times LB plus BH plus LH. This is the total surface area of a cuboid. Now, what if you have the top surface is open? For example, in a water tank, the top surface will be open. So if top or bottom is open, then we will not have one of the LB. So we will have 2BH, 2LH, but only one LB. So LB. We need this formula for solving few questions, so we will use it later on. Now coming to lateral surface area. You know, lateral surface area means we will only take the side faces. We will not take the top and bottom. So it will be 2 times BH and LH. 2 times BH plus 2 times LH, or we can simplify it in this form. 2 times 2 and H is common. So 2H L plus B. This is the lateral surface area of a cuboid. Also, this rule we need it to solve few questions. Moving on to volume of cube and cuboid. Actually, this is another lesson, but just I'm giving a short information only. Volume is the space inside the shape, and for a cube, all sides are same. So let's consider all of them are A. So the volume will be A times A cube. And volume of a cuboid, if this is the length, breadth, and height, volume of the cuboid will be L, B, H, or L times B times H. Now let us see the first question. A plastic box 1.5 meter long, 1.25 meter wide, and 65 centimeter deep is to be made. So we need to make a box. Most important information from the beginning, have a look at the units, meter, and centimeter. All of them should be same unit. Since here you have 2 of them in meters, and also the further details are also in meters, so we will convert centimeter to meter by dividing by 100. Centimeter to meter is dividing by 100, so this will be 0.65 meters. That's the first part. And let us mark it on the sides of the shape. So the length is 1.5 meters, width is 1.25, width and the breadth are the same. Hope you know it. Now the height, deep or the height is the same, which is 0.65 meters. These are the informations given, ignoring the thickness of the plastic sheet. So imagine it is so thin. Find the area of the sheet required for making the box. It is open at the top, so we have to apply the rule of total surface area, ignoring one of the faces. The real rule is 2 times LB plus BH plus LH. But from here, we don't have the top surface. So here it will be surface area. We have to apply the rule 2 times LH plus 2 times BH plus only 1 LB. Now let us substitute 2 times length is 1.5 times height is 0.65 plus 2 times 1.25 times the height again, which is 0.65 plus only one time length and breadth. Length is 1.5 times the breadth is 1.25. So when you simplify this, you will get the answer. So when you calculate, you will get 1.95 plus 1.625 plus 1.875, which will be equal to 5.45 meter square. That will be the total area. Therefore, area of the sheet is equal to 5.45 meter square. To answer the second part, the cost of the sheet for it, if a sheet measures 1 meter square, costs 20. We need 5.45, so total cost will be 1 meter cost rupees 20. So 5.45 meters will cost 5.45 times 20, which is equal to rupees 109. Let's see the next question. Length, breadth, and height of a room are 5, 4, and 3. So the length is 5. We can't change it. It is important. Breadth is 4 and the height is 3. Find the cost of whitewashing the walls of the room and the ceiling, which means we have to ignore the floor. Once again, length and breadth is ignored. So let us write down total surface area of a cuboid is 2 times LB plus BH plus LH. But here, the floor is ignored, which means L and B is ignored. So we have to take only one LB. So we have 2 BH plus 2 LH plus 1 LB. So let us substitute 2 times. Breadth and height is 4 and 3. Length and height is 5 and 3. And length and breadth is 5 and 4, which is equal to 24 plus 30 plus 20, which is equal to 74 meter square is the total area. Total cost is equal to, for 1 meter it is 7.5. So for 74 meter it will be 74 times 7.50, which will be equal to base 555. Moving on to question 3. The floor of a rectangular hall has a perimeter of 250 meters. The floor, so total perimeter. Perimeter means length plus breadth plus length plus breadth. So we know perimeter is equal to 2 times L plus B, which is given to us as equal to 250. So 2 times L plus B is equal to 250, or L plus breadth is equal to 250 divided by 2, 125 meters. We know the relation between length plus breadth is 125. That's all. We don't know separate what is length and breadth. But there are more conditions given to us. If the cost of painting the 4 walls at the rate of 10 is 15,000 rupees. So for 1 meter, it is 10 rupees. So total cost is rupees 15,000. Therefore, total area will be 15,000 divided by 10, because cost is equal to area multiplied by the rate. Now we know the rate and we know the cost. So to find the area, it will be cost divided by rate. So area is equal to cost divided by rate. That's what we did, cost divided by rate, which is equal to, so we find the area is 1,500 meters square. Now we know the total area of painting, and it is specified, it is only 4 walls, which means lateral surface area. Lateral surface area of a cuboid is equal to, we studied it, the L and B will be cancelled. So 2 times H times L plus B. From the rule 2LB plus 2BH plus LH, this part will be cancelled. So we will have only this and this for lateral surface area. And we can simplify the expression this way. And now we know L plus B is 125. So this can be replaced as 125 times height is missing times 2 is equal to, the total area is 1,500 from here. So we can rewrite in the form 2 times 125 is 250 times H is equal to 1,500, or H is equal to 1,500 divided by 250, which is equal to 6, and the unit will be meters because all of them are in meter. The question was, what is the height of the room? So the height of the room is 6 meters. Keep practicing. This is a really amazing lesson. That's all for today, and we will continue the exercise in the next period. Thanks for watching.